Math, used in banjo. The banjo, known for its bright and resonant sound, is crafted using mathematical precision in its structure, tuning, and acoustics. The circular drum-like body, string tension, and fret spacing all rely on mathematical calculations to achieve the perfect tone. Let's explore the role of math in the banjo. Banjo uses math in string length and tension. The banjo's strings obey the wave equation F equals 1/2 L through Tm, where the length L and tension T determine pitch. Tightening the strings increases frequency, raising the pitch. Circular drumhead and vibrations. The banjo's body is a circular membrane that vibrates based on mathematical wave models. Its resonance follows Bessel functions, which describe oscillations in circular systems. Fret placement and scale length. The fret positions follow the logarithmic formula Dn equals L, 1 minus 2 n's for 12, ensuring that notes are spaced correctly along the neck for accurate tuning. Bridge positioning and harmonics. The bridge is placed precisely at a mathematical ratio of the total string length to create harmonics that enhance sound quality. Mathematical principles applied. Logarithmic functions determine fret spacing for accurate notes. Wave mechanics describes string and membrane vibrations. Geometric symmetry optimizes the circular drumhead's resonance. Through mathematical precision, the banjo produces its signature twang, making it a key instrument in folk, bluegrass, and country music.